We're now looking at the average rate of change. And so just to recall back from algebra, when you were finding the slope, right, between 2 points. So the slope between 2 points, let's call them x sub 1, y sub 1, and x sub 2, y sub 2. Well, the slope, remember, was the same thing as your change in your y. And so that was the change in our y values. So y sub 2 minus y sub 1, all over that change in our x value, x sub 2 minus x sub 1. Another way to write this is with a triangle y all over a triangle x. All that's just saying is the same thing I just said in words before. Your change in your y value all over the change in x. Or sometimes it helped us to think of it as rise over run, right? Well, this was the slope if you're looking at it between 2 points, the slope between this line, right? This is x sub 1. That would mean this would be my y value is y sub 1. This would be my x sub 2, y sub 2. But maybe we want to find the rate of change between 2 points, and the 2 points between on that line or graph is not a line. So for instance, maybe we have a curve and we wanted to find the rate of change on that curve between x sub 1 and x sub 2. So we would find those points on the curve. And the average rate of change, and in this case, kind of looks pretty similar to what I want to get. That slope of that line there is pretty similar to that curve right there when I want to find the slope on that two curves. So the average rate of change between x equals a and x equals b. Well, again, all we're really doing is finding the slope between those 2 points. And so if this was our a value here, our first x value, and this was our b value, so if I plug in a wherever I see an x in my function, this is f of a. My y value I could rewrite as f of a. This is my b value here, my x equals b, so the y value there, right, is f of b. So I want to find the slope between those 2 points. And again, it's just like we were doing above. It's the change of your y value. So your f of b minus our f of a value, our y value, when x was a, all over b minus a. So that's our average rate of change. So it really doesn't give us the exact slope anywhere on this point, or actually it does somewhere in there, but It doesn't give us the exact slope because this is changing. And what our goal for this section and the rest of this chapter is to be able to find the instantaneous rate of change. What is actually happening at this value or some point? What is that change in our function? And so that might be helpful with business or medicine or a lot of different things. But so if you're looking at a function that tells you your profit or how much you're going to make, and you want to know the rate of change your profit is changing as you are making more and selling more product, then you would want your rate of change probably to grow faster. You would definitely want it positive. And the steeper it is, the more it's changing. And profit wise, we want more profit, right? So, and if it was negative, then your function is decreasing at that value, and you want to see how fast it's changing. Because that's our whole goal behind this section. So let's look at an example. So we want to find the average rate of change. And let's say f of x is equal to negative 4x squared minus 6. And we want to look at this between x equals 2 and x equals 6. So basically all we're doing is we're finding those 2 points on the graph or on this equation. When x is 2, let's figure out what our y value is. So we want to first find our points. So let's look at f of 2. So we're going to go in there, wherever we see an x, we're going to replace it with 2. So let's rewrite it with parentheses wherever we see the x. So we have a negative 4. I see an x, so I'm going to put parentheses. I'm going to square it and then subtract 6. Now put in 2 where you see the inside the parentheses. And then order of operations. So exponents first. So negative 4 times, well, 2 quantity squared is 4 minus 6. Multiplication comes before subtraction. So negative 4 times 4 is negative 16 minus 6. Both negative, add them together, and the result's negative. So negative 16 minus 6 is negative 22. So basically, this is a point at 2, negative 22. And so now we want to figure out what the point is when x is 6. So if we look at f of 6, so going in and plugging in 6 wherever we see an x in our equation, we have 4, see an x, so parentheses squared minus 6. Put 6 inside the parentheses and simplify. So we have 4 all times 6 squared. So 4 times, well, 6 squared is 36. 4 times 36 minus 6. 4 times 36, well, 4 times 6 is 24. I'm going to carry my 2. 4 times 3 is 12 plus 2, so 144. So 144 minus 6, which gives us 138. So we have a point, in this case, at 6, 138.
Professor,
Yeah.
is there a negative sign in front of the 4?
Oops, there is. Thank you. I dropped it on the second time. So that's going to change everything, huh? So let's put that negative back here. So we have, thank you, 6 squared is 36. Still negative 4 here. Only thing that's going to change is this is now going to be negative 144 instead of positive. And so negative 144 minus 6 is negative 150. So we have a point at 6, negative 150. So we want to find the slope between these 2 points. So the change in y is a negative 150 minus the change the other way, so minus negative 22, all over, as long, you need to be consistent. I started with this y value, I need to start with this x value in the denominator. So 6 minus 2. So order of operations, treat numerator as a parentheses and denominator as a parentheses, and then we do the division. And so we have negative 150 really plus, because a minus and a negative is plus. So 150 minus 22. Could have done this in my head. So that's 128. So that's going to be a negative 128 in our numerator. All over 6 minus 2, so 4. And 4 goes into that evenly. And so it's negative. Negative divided by positive is negative. Well, 4 goes into 12 evenly 3 times, and 4 goes into 8 evenly twice. So negative 32. So the average rate of change between those 2 points, or x values, is negative 32. So now we're looking at an example, find the average rate of change of g of x equals the square root of the quantity 3x minus 2 under that radical. And we're finding that between x equals 1 and x equals 2. So again, we want to find the points. So we want to figure out what is the point when x is 1 on g of x. So let's look at g of 1. So go in and plug in 1 wherever you see an x. So this is equal to the square root of 3 all times 1 minus 2. And so this is equal to square root of 3 minus 2, which is the square root of 1, which is 1. So we have a point at 1, 1. So now we want to figure out what's going on when x is 2. What is that point? So g of 2. I'm going to go in and plug in 2 wherever we see an x in g of x. So we have square root of 3 times, we're going to place 2 in there, and then minus 2. So this gives us back the square root of 3 times 2 is 6 minus 2. So the square root of 4, which is 2. So we have a point at 2, 2. So we want to find the slope between these 2 points. So change in y, so 2 minus 1, all over the change in x. So 2 minus 1 again. So that gives us 1 divided by 1, which is 1.